So, we are discussing basically basic tools and apparatus in the laboratory. So, I was discussing in 5th lecture, that is the galvanometer, and 4th lecture I was discussing about the screw gauge and slide calipers. So, just one mistake I did probably. So, I will just rectify it. So, in screw gauge about 0 error. So, in this case it is a negative 0 error, because it just cross this 0 of the linear scale, right. So, I was taking this 0 error, the reading it is coinciding. So, this 45 or 46 it is coinciding with this linear scale 0, but that is not correct. Actually this 0 of this circular scale. So, where it is with the linear scale. So, what is the how many so from this 0. So, it is crosses this how many division of circular scale. So, that we have to take here, basically it crosses I think the 0. So, this 1, 2, 3, 4 yeah, from this 0 to this 0. So, these 4 division of the circular scale, it crosses this 0 of linear scale. So, this basically error is this 4 or this 5 division into this least count. So, that will be the 0 error. It is the negative 0 error, means minus this 4 into least count 0.001. So, it is basically 0.005 minus 0.005. So, that will be the 0 error, and in this case also. So, this how many division between these two 0, So, it is around 3 division. So, this error is basically in this case positive error. So, plus this 3 division into least count 0.001. So, plus 0.003. So, that will be the least count. It is just slightly different from the slide calipers. Slide calipers we are seeing this when 0 of the vernier scale, it is so that it coincides with how many division of the this main scale. So, that we took, and in this case just we are taking the number of division on circular scale between these two 0. Okay. Between these two 0, what is the number of division on circular scale. So, that division, number of division into the least count. Okay. So, that will be the 0 error. So, in this case is negative minus, in this case plus. So, this if you consider this plus or minus error here. So, this minus will be minus plus minus, minus into minus will be plus. So, that is a negative error will be added with this main reading, and this positive error will be subtracted from this main reading. Okay. So, I will go to the today's topics. So, this voltmeter and ammeter as well as multimeter we will discuss in this lecture. So, I was showing you these 3 main tools apparatus we use in our laboratory when we do electrical circuits. So, these are the common tools, common apparatus we use, and I was discussing about the galvanometer. Okay. So, today I will discuss about the voltmeter and ammeter. So, what we have what I told about the galvanometer. So, galvanometer is basically a galvanometer is a device used to find the direction of current and its magnitude. So, direction of the current and it is the magnitude of the current, that is we determine, we find out from the galvanometer. Okay. So, galvanometer is basically it has a very small resistance and is connected in series in the circuit. Okay. So, that I will show you. So, this small resistance of the galvanometer, from where this resistance is coming. So, basically galvanometer have this rectangular coil. Okay. Now, on top and bottom of this coil, this, as I told, these two spiral springs are there, right. Now, the one end of this circular rectangular coil, this connected with this one end of the spring, and other end of the rectangular coil is connected with the one end of the bottom spring. Okay. Other end of the spring, this basically is connected, that is the we are taking these two wires as a connector of the galvanometer. Okay. So, that means when, so this, when it is connected in circuit, so these two end is connected in circuit. So, when current will flow through this, okay, so it is going through this spiral of the spring and then this rectangular coil and then this spring. Okay. So, basically this resistance is due to the spring and the rectangular coil. So, that is the resistance of the galvanometer. Okay. Now, here just yesterday I mentioned that because of torque there will be rotation of this rectangular coil, and pointer is connected with the rectangular coil, that pointer will move on the scale. Okay. So, this angle of rotation, that is the basically is proportional to this to the current in this coil, and whether it will go towards positive or towards negative, it will depend on the direction of the current. So, thus one can find out the magnitude and direction of the current in the circuit using this galvanometer, right. So, torque and force, what is the difference between torque and force? So, due to torque there will be rotational motion, and due to force there will be translation motion. Okay. So, when we consider translation motion, so force is responsible for this translation motion. When we consider the rotation of a body, so torque is responsible for this rotation. Okay. So, in this case our coil is in a magnetic field, in a radial magnetic field. Why we need radial magnetic field, that I have explained. Okay. So, in this case, so this torque for this type of situation, for this type of situation. So, this, because here current is flowing through a, we can consider through a coil, means through the conductor. Okay, through the conductor, it has length, breadth. Okay. So, torque on a current carrying conductor in a magnetic field, that you know that torque equal to, basically force is I dl current passing through this. So, this is the current carrying conductor, that element. Okay, I dl, current carrying element I dl cross B magnetic field. So, that is the force into this as I mentioned that there will be two force in opposite direction on this arm and this other arm, that force magnitude or this force is this. Okay. So, and these two force, their perpendicular distance is B, perpendicular distance is B. So, force into that distance, okay, between these two force B. So, this force cross product of B will give you torque. Okay. So, this way one can find out the torque. Another way to find out the torque is, if a magnet of moment is in a magnetic field, then torque is m cross v. M is the magnetic moment of the magnet which is placed in a magnetic field B. So, m cross v, that will be torque. So, that torque will work on this magnet. Okay. So, here what is the, from where this magnetic moment is coming? So, you know that the magnetic moment of a closed current carrying loop, if any closed current carrying loop, it is whether it is rectangular or circular. Okay. So, it is equivalent to a magnet and its magnetic moment is m equal to I A. I is the current flowing through the closed circuit and A is the area of this closed circuit. So, here it is closed circuit. So, area is L into B, right. A is L into B, okay. And so, m is I L B, m is I L B, m is I L B. So, L B is basically area. So, I have written area A or I A directly from here. So, m if I replace by I A, so I A B. So, that since they are in perpendicular direction etcetera. So, one can consider the direction and that tau will be I A B. Okay. And here also, from here also I can get that these two are equivalent, equal. So, because I torque equal to I L cross B small b. Okay. So, this is force into this that B distance, this couple basically between these two force. So, this I can write I L B B, I L B B. So, cross product from there, since they are perpendicular to each other. So, sin 90 degree. So, from cross product sin 90 degree will come, and so that basically 90 degree 1 sin 90 degree 1. So, that is why you will get I L B B. L B is A. So, I A B. So, from here also, from this definition of torque, in this case you are getting torque I A B. If you take this definition, okay, of torque, then also you are getting tau equal to I A B. So, basic of this both formula is basically Lorentz force. You know the Lorentz force. What is Lorentz force? When a charged particle moving in a magnetic field. So, this force act on this moving charge, and that force is Q V cross B. V is velocity and B is the magnetic field and Q is the charge. Okay. So, here current is flowing means charge is flowing with time. So, basically Q by T, that is the current. Okay. So, and V is basically distance by time and current is charge by time. Okay. So, here this is the force and I need to find out torque. So, torque is this force into again B. So, again these two force in these two arm, there will be two force in opposite direction, okay, because current in this direction, if it is up then it is down. So, velocity is if up of charge, then in this case it will be down or just vice versa. Okay. So, two force and their perpendicular distance is B. So, force cross B, okay, that distance. So, that will be torque. So, now I can write tau equal to Q V B, okay, Q V B, and then this B again in this case V B, this B all are perpendicular to each other. So, that is why it just directly it will come, and what will be the ultimate direction of the tau, that is the axis of rotation, that one can find out, right, from cross product. Okay. So, this I can write tau equal to Q V B B. Okay. So, now Q V I can write velocity, that is the So, velocity of charged particle along this length L. So, L by T I can write velocity L by T if a charged particle takes time T to cross this length L. Okay. So, I can write L by T B B. Okay. So, now here just slightly we adjust it Q by T, I can write Q by T into L B B. So, Q by T is I, L B is A and this B magnetic field B. So, here also from here also tau equal to I A B. Okay. So, for this case what is the torque? So, there are many ways to find out. Okay. So, but this is the basic one, Lorentz force. From Lorentz force you can get this result which is same as you can get from other formalism. Okay. So, that was the galvanometer. Now, what is ammeter or voltmeter? Let me tell you this. So, what is ammeter? What is ammeter? So, ammeter is nothing but galvanometer. It is a low resistance galvanometer. Ammeter is a low resistance galvanometer and it is used to measure current in a circuit. Okay. And this is a circuit, typical circuit, electrical circuit, and this ammeter we connect in series, okay, in the circuit. So, we are telling this ammeter is nothing but a galvanometer, but low resistance galvanometer means resistance of ammeter is lower than the resistance of the galvanometer. Okay. So, what it is giving us advantage, instead of using the galvanometer we are using ammeter, and how we are making the resistance of the galvanometer lower to use it as a ammeter. Okay, that is the question. So, here basically I do not know, you can see this the I think I need to zoom it. So, this part to show you. So, this just this symbol ammeter. So, I have taken here, this is nothing but this galvanometer and this one resistance I have added here, okay, this parallel to the galvanometer. Okay. So, this is called shunt S, okay, and this is the two end of this external end of this galvanometer. Now, it is basically ammeter after adding this shunt resistance in parallel. Okay. So, this is this combination galvanometer and a shunt resistance is parallel. So, this is a ammeter. Okay. So, that is why we are telling ammeter is nothing but a galvanometer, but this arrangement gives the resistance of this ammeter is lower than the resistance of the galvanometer, same galvanometer. Okay. So, you know shunt resistance is very small resistance. Okay. It is very small than resistance of the galvanometer or resistance of the of this R used in circuit. Okay. So, this shunt resistance is connected with galvanometer in parallel. So, total resistance of the ammeter, then what will be the total resistance of the ammeter? If it is R A, so they are in parallel. So, you know this how to find out, 1 by R A equal to 1 by G plus 1 by S. So, from here R A is basically G S by G plus S. Okay. So, this is basically is less than G and even less than S. Okay. So, total resistance of ammeter is even less than the shunt resistance, and shunt resistance is lower than this galvanometer resistance. Okay. So, resistance of the ammeter is very low than the resistance of the galvanometer. So, using this shunt technique, we are reducing the resistance of the galvanometer to a very small resistance. Actually, this resistance in ideal case and in ideal ammeter, this resistance generally it's taken as a 0 resistance or tends to 0 resistance. Okay. So, why we need to make it smaller resistance, 0 resistance or very small resistance, because in my circuit, okay, current is flowing and that current I want to measure. For that I am using an instrument that is called ammeter. So, that ammeter I am connecting in a series of in series of the circuit. Okay. So, that means I am adding resistance in the circuit. Okay. So, then if you add the resistance in the circuit for a particular that constant voltage, so current will change in the circuit, but that I do not want. I want to measure the current flowing in the circuit. For measurement I am using an instrument ammeter. When I am using adding in the circuit, current in the circuit should not change. Okay. If it changes, then I will not get the actual current flowing in the circuit which I want to measure. Okay. So, now see the difference. Galvanometer also used to measure the current, ammeter also used to measure the current. So, why? So, what is the difference in measurement of current? So, if you use galvanometer here, so it has resistance G. Okay. So, then actually it will change the actual current of the circuit, okay, which I want to measure. So, that is why galvanometer is used to basically measure the direction of the current and just approximately magnitude of the current. Okay. So, it cannot give the accurate current. Okay. So, if you want to get the accurate current in the circuit, so you have to use ammeter. Okay. So, that is the difference. So, ammeter is a galvanometer, but it has negligible resistance. So, using shunt that we have make it, and it is used in series. It is used in series. Okay. So, how to calculate shunt, etc. What is the value of the shunt that one can find out. So, I think this standard I will not discuss it, but here important is that how this galvanometer is converted to the ammeter and why it is done for measuring the current. Okay. So, that I tried to explain. So, in reality I have one I think, yeah. So, where was that? Yeah. So, yesterday I have showed you, I opened the galvanometer, and I showed you all parts. So, here also you can see nicely I have opened. So, this galvanometer, so I opened it and showed you all parts. Okay. This is the, I think, external this connector for this galvanometer. Okay. So, here I opened and showed you, okay, this magnet and this rectangular coil is placed I need this I think here. So, I think so here I showed you this rectangular coil, right, rectangular coil. So, this is the rectangular coil, right, and this two spring also I have shown you, two spring, one is at bottom and one is at the top. So, in figure I think Okay. So, this is the pointer also, this is the pointer, no, it will move on the scale, it will move on the scale. Okay. So, now this permanent magnet, as I told this, it gives radial, so it is a horseshoe kind of pole pieces. So, it gives you this radial magnetic field. Okay. Now, so electrical connection we take from this bottom and one from the top. Okay. One from the top. Okay. One from the top and another from the bottom. Okay. Another from the bottom, I think, yes. Okay. And total resistance, as I told, this coil and spring, that will be the resistance of the galvanometer. Now, yeah. So, I think in figure here it is more clear, here just check it. So, I have taken picture. So, this is the rectangular coil, this is one spring, this is one spring and this is another spring. Okay. And this connection is taken from here and it is taken from here. Okay. So, this two connection is taken and current will flow through this and go out. If I go the, I think this is the voltmeter, let me okay, let me show the voltmeter first and then I will discuss. So, this is the galvanometer. Okay. So, here if I with this now this galvanometer is converted to the voltmeter. So, I have opened one voltmeter. So, what is this? This is the voltmeter, right. If I open it, okay, if I open it, so here I have not opened completely. So, this here this part you are seeing as the same as this one, you know, already I have opened, this part is same as this one, you can see. Okay. So, that means the galvanometer, this is the galvanometer, main part of the galvanometer, rectangular coil, etc. So, that is there. Now, here I will show you that resistance, in case of ammeter, resistance is connected, the shunt resistance is connected in parallel to this galvanometer, and in case of voltmeter, high resistance is connected in series with this galvanometer. This is the difference, right. So, that I will show you in calculation. So, here just I will show you the that these two are the external connection. Okay. So, now if you just see it, this one, okay, here this, right, here this one, right. I think I need smaller one. So, this one, right. So, this you see, now from this you see one that high resistance, two resistance is connected and this part is going to here at the bottom of this circuit, at the bottom of this circuit. So, this actually this from the bottom of this galvanometer, whatever the connection, now it is in this case is directly connected, Now, in this case it is connected, that resistance here, basically two resistor is connected and this is coming. Okay. So, and other one is just directly connected, to the stop, okay, through the top. Okay. So, when current will flow through this, so current is not going to the galvanometer, the resistance directly. So, current will go through this series resistance, high resistance and then galvanometer resistance and then come out. So, here basically in this case, so this high resistance is connected in series. So, here I have shown you that same, from the same I have taken picture. So, this the high resistance is connected in series of this galvanometer, right. So, I think here it looks better. here it looks better. So, here also you can see this is the galvanometer structure, okay. And with this galvanometer structure, that spring here also you can see in better way, the one spin up and one spin down. And then I think this is the coil, this is the coil, rectangular coil. Now additional this here, this part I have zoomed, and you see this series resistance is connected, right. Series resistance is connected this way, and other connection is just on the top of this galvanometer resistance. So, this the this is an galvanometer of high resistance. So, voltmeter is basically a galvanometer of high resistance. Okay. So, what is the galvanometer voltmeter? So, voltmeter is basically a galvanometer. Voltmeter is basically a, here just I have shown you. Yeah. So, voltmeter is a high resistance galvanometer and used to measure resistance difference between 2 points in the circuit, right. So, it is connected in parallel to the circuit. So, ammeter is connected in series to the circuit, but in this case it is connected in parallel to the circuit, and ideal voltmeter must have infinite resistance. In case of ammeter, it is the 0 resistance, and in this case infinite resistance. So, why I need infinite resistance? Because again in circuit I will connect this voltmeter to measure the voltage between 2 points, and this whatever the voltage drop across these 2 points against, I say, across this resistance I have shown in the circuit, additional resistance. So, what is the voltage drop or potential difference across this resistance, that I want to find out. So, for that I am using voltmeter, and voltmeter is nothing but an infinite resistance. Okay. So, I have connected in parallel. So, this mechanism is such that when I am using this measuring apparatus in the circuit, it should not change current in the circuit. Okay. So, if I connect in parallel, now you can see this, what will be the resistance of this part, what will be the resistance of this part. Resistance of this part will be 1 by R total equal to 1 by resistance of the voltmeter, means that is resistance of the galvanometer plus additional resistance in galvanometer we have added as I showed you, here. So, this galvanometer resistance and this resistance in the yeah. So, I need to, they are not showing. So, where I have kept it, yes. So, additional resistance, this RV I have written. So, that is the basically additional resistance of this is RV, and G is the resistance of the galvanometer. So, here you can see this 1 by G plus RV, that is the resistance of the voltmeter, and 1 by R2. Okay. Now, this if it is very high, it is towards infinite. So, that means this part is 0, this part is 0, 1 by this infinite resistance, very high resistance. So, you can take 1 by this, so it is close to 0. So, you can neglect this part. So, then 1 by R total equal to 1 by R2, that means R total equal to R2, that means this part having the resistance what, that is original resistance in the circuit. So, addition of this voltmeter is not changing the resistance in the circuit. So, there will not be any change in the current in the circuit. So, this the mechanism is such that this galvanometer we are using, and then resistance we are adding to this galvanometer in such a way, then it is becoming ammeter or voltmeter. Now, this ammeter or voltmeter again we are using in the circuit in such a way that it should not change the original current in the circuit which I want to measure. So, if original current does not change, then I can measure the current, get the current from ammeter. I can get the accurate voltage drop across this, because R is fixed, R2 is fixed. So, if current is fixed, it does not change. So, this I into R2, that will give us the voltage. Okay. So, if there is no change in the circuit, there is no change of the current in the circuit, then I can get the actual current and actual voltage drop across the 2 points which I want to measure for that. So, this way we use voltmeter and ammeter. Okay. So, I think yeah. So, then I just show you the ammeter. So, in ammeter, here I have ammeter, again I have opened it, I think I have opened it, okay, ammeter I have opened it. Now, just okay, inside part is I have kept in a box, just separated it. Okay. So, this was inside of this one. Okay. So, here you see it's I can show you here this again this has magnet, and that this galvanometer, right, galvanometer it has so inside you have this coil, you can see I have yeah. So, I think this is the coil. Coil means this spring, spiral spring, and then this rectangular coil also there. And so, in picture here I have taken, here you can see better, here you can see better, it is same ammeter, microammeter as I showed you. Here you can see this is the spring, top spring, there is a bottom spring, and connection is taken from the top one and connection is taken from the down one. Okay. So, here the shunt resistance is connected, but I am not able to see here, but I think it is broken. So, so this you see again this ammeter, it is a nothing but galvanometer, but a series a resistance, shunt resistance is connected in parallel. So, one has to connect in parallel, but here either it is inside which I cannot see. So, again what information is that this is the galvanometer, but additional shunt resistance one has to add in series in parallel. So, that is not visible here from outside. Okay. So, I think this is the information about the galvanometer, then how it is converted to ammeter, and then how it is converted to. So, nowadays, so we have very good multimeter. Okay. So, multimeter is basically it is voltmeter and ammeter, and some more things you can measure. You can measure directly resistance, you can measure directly the current flowing through the circuit. Okay. And also many more things you can measure. You can check this here, you can see this, you can check this I think this I have taken picture of this one. I have to, you can switch on this power on, power on. So, here you can see this this common, and then if you want to measure voltage. So, this is the voltage. If you want to measure current, their current, see in millimeter order current, this if you want to measure ammeter ampere order of current. So, you have to take this red one here, okay, and this to end. So, I think you are familiar to use this. So, what I want to tell you, these are the very basic tools in the laboratory, and you should be familiar and you should be happy to use them whenever you need, and this is very useful tools to check your circuit. Okay. So, whether it is conducting or not, where you want, you prefer to good conduction. So, after connection you can check between 2 points that whether its resistance is high or low. So, what you want to measure here. So, if you want to measure voltage, if you want to measure even frequency, one can measure. Okay. AC voltage also one can measure, and you can measure the capacitance in is F is written capacitance, F is written, you can measure capacitance, you can measure H means Henry, okay, inductor, okay, inductance you can measure, inductance, capacitance, resistance, you can measure using this one. Even you can measure this, check this NPN, PNP transistor also. So, these are the that is how it is called multimeter, it has multifunction. So, but it cannot replace the voltmeter ammeter, you know, because in circuit. So, that is for dedicated one and this for handy one, you know. So, in circuit, for dedicated circuit, so we need to use voltmeter ammeter, but this is this handy one, just temporarily if you want to check, then we use this multimeter. So, here just I showed everything you know, but I just repeat it just to encourage you to use them. Okay. Without hesitation you should use the instrument in the laboratory. Okay. So, I think I will stop you. Thank you for your attention.